Hello, ladies and gents. We're moving on to 9.2, day 1. Here is your problem of the day. Don't be scared that they're fractions. Just know that fractions means division. To get rid of the fraction, you have to do the opposite of division. So you have to, let's get to draw here. The opposite of division, you have to do multiplication to get rid of this denominator and be left with x. So the opposite of dividing, I said, is multiplying. So we're going to multiply by the same number that is on the bottom. So multiply by 7 here, times 7. It's technically, if you want 7 over 1, 7 over 1 doesn't change anything. 7 divided by 1 is still 7. Here's where you can cross cancel. So I am going to, if I divide both 7 and 7 by 1, or by 7, you get 1. You're left with 1 everywhere. 1 times x is just x. We are left with x. And whatever you do to one side, I do the other. And what I do to this side, I multiply it by 7. So multiply by 7. And 7 times 9 is going to get us 63. Final answer. All right, now it's your turn. Let's pause the video right here, and now you try it out. So do the opposite of dividing, and is multiplying, and you have to do it to both sides of the equation. Okay, hopefully you tried that on your own. If you were stuck, here's how this problem goes. So x divided by 5, opposite of dividing, as we said, is multiplying. So I'm going to multiply by what the denominator, what is on the bottom is denominator. So I'm going to multiply by 5. These cancel, so they turn into 1 because I can divide both of them by 5. 5 divided by 5 gets me 1. 5 divided by 5 gets me 1. Now I multiplied 5 on this side, so I have to do the same exact thing on this side. So I'm going to multiply by 5. I am left with x equals 5 times 5 is 25. Final answer. Okay, we are continuing. We are going to be reflecting. We are going to reflect an image. Let's just say reflect. Let's change that. Oh, I'm still drawing. Okay, we're going to reflect an image from a pre-image on a graph. So reflecting, so if you think of the word reflect, what do you think that means? What are some ways we can use the word reflect? Something like reflection. Where have you heard the word reflection? Maybe in a mirror. Maybe you've seen your reflection in water. What do you normally see in a reflection? Do you see something else? Hopefully not. Hopefully if you look in the reflection of your reflection in a mirror, you should see yourself. And yourself should still be the same, correct? So you should not change unless you are looking at those weird carnival mirrors. Those change what you look like. But if you look in a normal mirror, a normal reflection should be an identical copy of yourself, but sometimes yourself is backwards. So we're going to be having some fun with reflections today. You know what pre-image is. It's what the starting shape. The image is the end shape. A transformation is just a change. So all these are transformations. Reflection just means we're going to flip it. Orientation, I showed you, is if it's the same layout direction. It's if it spins, is it still facing the same way? Congruent just means the same. Line of reflection, it'll be easier for me to show you what that is. It's basically the line where the shape is going to flip over. Here are our directions, our steps. We're going to highlight the line of reflection because that's going to be super important. Most common mistake is that students most likely flip over the wrong axis. So we're going to highlight that to make sure we count correctly. We're going to count the distance from a point to the line of reflection. And then we're going to count the same distance on the opposite side of the line of reflection and draw a point. We're going to draw like A prime or B prime. We're going to repeat steps 2 and 3, not 1, 2, and 3, just 2 and 3 until all the points are done. So here's my example. So it says reflect over the x-axis. So we need to highlight the line of reflection. The line of reflection, they tell us, is the x-axis. Is this the x-axis? No, that's the y. Here's an x. This is the x-axis. So I am going to highlight, because that was the step, highlight the x-axis. This is the line my shape is going to jump over. So I'm going to now pick, let's pick blue. Now I'm going to, then it says count the same distance, count the distance from a point to the line of reflection. So I'm going to pick X. I'm going to pick X here, and I'm going to count how many spaces away is it from the line I highlighted. Well, I see that it is 1 space away. So if it's 1 space away from this line, it's going to be 1 space away from this line. So this is where, and for now, remember I just drew lines to show you, but I'm actually going to erase those. So it's 1 space away there. So it's going to be 1 space away here, and so I'm going to put X prime. Now let's do another one. Let's go to Y. I see Y is 1, 2, 3. 3 spaces away, so I'm going to keep counting another 3. 1, 2, 3. And this is going to be Y prime. Let's do Z. 1, 2, 3. Keep going. 1, 2, 3. And this is going to be Z prime. Last one, W is 1 space away from the line, so we go 1 space away from the other line. This is going to be W prime, and now I'm going to connect all my dots and make the image. And let's get in a habit. This was the pre-image. This is the image. You should notice my shape should look identical. These shapes are exactly the same. However, it should look flipped. It is the mirror image on the other side. So if I were to pick this shape up and pick it up, cut it out, and flip it over, it would be exactly the same. The dimensions are all the same. The distance away from this line is exactly the same. Okay, we're going to now work on these two together. Make sure you pay attention. Reflect over the y-axis. Highlight the line of reflection. The y-axis. Is the y-axis right here? Is this the y? Oh, is that the y-axis? Hopefully you said no. Find y, and we're going to highlight. Oops. Let's highlight the y-axis. Okay. Now we are going to count the distance from a point on the line, from a point to the line of reflection. So I'm going to pick green, and it is, let's start with B. It's 1, 2 spaces away, so I'm going to count another 2 spaces. 1, 2, and this is now B prime. Very thick pen. Okay, let's go to A. So A is 1, 2, 3, 4, 5. So I have to count another 5. 1, 2, 3, 4, 5. And that is where A prime is going to go. What about C? Is 1, 2. So I'm going to count 1, 2. So C is C prime. And last but not least, D. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. This is D prime. Okay, let's connect our dots. There we go. Your shape should look identical, but it is flipped over the line. It is a little bit backwards. Notice how it goes A, B, and then it goes B, A. This is DC, and then it goes CD. So they should be the shape, the size of the shape has not changed. The orientation technically has not changed. It's still like facing up, I guess. Or maybe the orientation technically has changed. But either way, the shape did not change, and it's exactly 2 spaces away from the line of reflection. All right, last one. Reflect over the y-axis. We got another y-axis, so we are going to highlight the y-axis. All right, this one's a little tricky. How many spaces away from the line is A? If you answered 0, you are correct. So this is also actually going to be A prime. Now let's count how many away B is. 1, 2, 3. So B is also going to be 1, 2, 3. And this is B prime. D is 1, 2. So we go 1, 2. D prime. And C is 1, 2, 3, 4, 5. So I'm going to go 1, 2, 3, 4, 5. This is C prime. And now I'm going to connect my dots, including that first one. Ta-da! Same shape. It just flipped over. So if your dot touches the line of reflection, it's just going to stay on the line of reflection. And there you have it. My shape is the same. This is 1, 2, 3. This is 1, 2, 3. Everything looks the same. It's just a perfect mirror image across the y-axis. Let me know if you have any questions.